So what we're going to talk about today, just kind of a wrap-up of Unit 1 with our whole numbers, is we're going to talk about factoring and divisibility. What divisibility means, or what being divisible means, is that one number will divide into another without a remainder. So if we say that 16 is divisible by 2. 16 divided by 2 is 8. There is no remainder, no decimal, no fraction involved. It divides out to be a whole number. Now, as we're looking at numbers, to tell if something is divisible by another number, there are some tricks. For something to be divisible by 2, it must be an even number. What do we mean to be an even number? Well, the last digit is 0, 2, 4, 6, or 8. So the rest of the number doesn't matter. It could be 789,374. It's divisible by 2 because the last digit is 4. How do we tell if something's divisible by 3? Nope. Nice try, though. We look at the sum of the digits. Let me do this. 924,852 is divisible by 3 because if we add the digits, what's 9 plus 2? 11 plus 4? 15 plus 8? 23 plus 5? 28 plus 2 is 30. Is 30 divisible by 3? Yes, it is. So therefore, the whole number is divisible by 3. If you add up its digits and that sum is divisible by 3, the whole number is divisible by 3. Oh, yeah? It is divisible by 2 as well, but it's also divisible by 3. Now for 4, there is a rule, but it's not very useful. The rule for 4 is if the last 2 digits combined are divisible by 4. Like, let's do the 924,852 again. If the last 2 digits are divisible by 4, like 52 is divisible by 4, then the whole thing is divisible by 4. But for our purposes, we're going to say there really isn't a rule because we don't need a rule. Because to be divisible by 4, you can just divide by 2 twice. How can you tell if something's divisible by 5? There you go. Ends in 5 or 0. That's pretty simple. 6. Well, again, we're going to say there is no rule. There is none. That was weird. Yeah, just the connection went faltered for a second. There is a rule for 6. What the rule for 6 is if it's divisible by both 2 and 3, then it's divisible by 6. But again, why would you worry about it? You can just divide by 2 and then divide by 3. 7. There is no rule in existence for telling if something's divisible by 7, so you just have to try to divide by 7. If you can come up with a rule for dividing by 7, let me know. I'll become rich and famous, and I'll share a little bit with you. 8. Again, for 8, we're going to say there isn't one. There is one for 8. 8 involves the last 3 digits of a number. If the last 3 digits of the number are divisible by 8, then the whole number is divisible by 8. But dividing the last 3 digits of a number by 8 is pretty difficult in itself, so it's really not very useful. 9 has a rule. Again, but for 8s, we can just divide by 2 a couple of times and you're good. The rule for 9 is the same as the rule for 3. It's the sum of the digits. If you add up the digits and that sum is divisible by 9, you can divide the whole thing by 9. How about 10? Ends with 0. So that's the easy one. Now, as we get larger, there are other rules for what we call the prime numbers. So let's talk about that for a second. prime and composite. A prime number cannot be divided by anything other than 1 in itself. That's a prime number. Has no numbers that divide into it other than itself. So the rest of these are what we call composite numbers. Composite numbers have smaller numbers that do divide into them. So as we go larger from 10, most of the numbers we run into are composite, like 12, 14, 15, 16, 18. They're all made up of smaller numbers multiplied together. The prime numbers, like 11, 13, 17, 19, and so on, those would be helpful if we had divisibility rules for them. And we do have divisibility rules for most of them, but it's just they start to get so complicated, it's just not worth the trouble. For example, let me show you the rule for 11. I'll give you a number here, 8, 7, 2, 5, 9, 3. To tell if that is divisible by 11, you take every other digit, 8, 2, and 9, you add them together. What do we get? 19. Then you take the rest of the digits, the 7, 5, and 3, add them together, and you get 15. The difference between those is 4. If that difference is either 0 or divisible by 11, then the whole number is divisible by 11. So this number is not divisible by 11. However, if this were 8,000 or 872,589, let's try that. 8, 2, and 8 make 18. I screwed that up. Should be a 6 here. That's 18. And then 7, 5, and 6 make 18. The difference between them is 0. So that number is divisible by 11. Okay. It is a weird rule. It's like I said, it's so tough, it's so difficult to do, it's not worth remembering. You've got, as I said, you've got calculators, just I'll punch it in. So anyway, what we're going to focus on for now then is the composite numbers. We said the composite numbers can be broken down into smaller numbers. Those are called factors. For example, if I give you 36, there are all sorts of sets of factors for 36. We could have 4 times 9. That's a set of factors. 3 times 12. 6 times 6 is a set of factors. We could do 2 times 18. All of those are sets of factors, or what we call factor pairs. So if I ask you to factor 36, which one am I looking for? Well, as we said before, in math, we like to have 2 people to do a problem and get the same answer. So what we typically look at is what's called prime factoring. If I ask you to prime factor 36, what I'm asking you to do is break it down into as many small pieces as you can until all the pieces are prime numbers. So what is one number that divides into 36? Not everybody at once. 2, there, here you go. If I divide 36 by 2, what's left over? 18. Is the 2 prime? Can 2 be divided by anything else? No. 2 is prime. Oh. So I'm going to circle the 2 just to signify that I'm done with it. 18 can be divided by 6. What's left over? 3. 3 is prime, I'm going to circle it. 18, however, can be broken into 2 times 3. Or 6 can be broken into 2 times 3, right? So there's my prime factoring. If I ask you to prime factor or factor, yes, that's what I'd be looking for. So 36 is equal to 2 times 2 times 3 times 3. Or if I ask you to prime factor...
And that's what we've got our answer as, is 36.
Yep, that's it. In fact, you could just write that if you wanted to.
All right.
What if I ask you to prime factor 60? 10. Okay, what's left over if you divide by 10? 6. Okay, is either of those prime? Say no. 10 can split into 2 times 5. Those are both prime. 6 splits into 2 and 3. Those are both prime. Because it can be divided into smaller numbers.
Oh, you can divide it down. Oh.
So we've got 2, 2, 3, and 5 if I put them in order from smallest to largest. So 60 is 2 times 2 times 3 times 5. So the question might come up, why do we care? Why is factoring a good thing? Well, there are going to be things that we need to find, especially when we work with fractions in our next unit. Least common multiple, which is the same as find the least common denominator. Least common denominator applies specifically to fractions. Least common multiple can be any generic number. Let's say I tell you to find the least common multiple, or LCM, of 18 and 30. I can do that by factoring. If I factor 18, what do I get for factors? Well, 18 splits into 2 times 9 and 3 times 3. So it is 2 times 3 times 3. How about 30? 30 will split into 10 times 3. 3 is prime. 10 splits into 2 times 5, right? So we've got 2 times 3 times 5. To find the least common multiple. Now, I'm not going to make you do this yet. This is the next unit, though, we're going to come back to do this for least common denominators. If I wanted to find the least common multiple, they have to have all the same factor. Well, they already both have a 2. They already both have a 3. The thing is, this one has an extra 3, so this one needs another 3. And this one has the 5, so this one needs a 5. They now both have exactly the same factors. If I multiply this back out, I get 90. If I multiply this back out, I get 90. The least common multiple of those is 90. Does that make sense? Kind of. So if I ask you to find the least common denominator or least common multiple of 15 and 12. Factor 12 and factor 15. What are the factors of 12? 2 times 2 times 3. If you break the 6 down into 2 times 3. So 2, 2, 3. 3 times 5 for 15. Yep, so we look at, they've already got 3's. This one needs a 5 and this one needs 2 2's. So 12 times 5 is 60. 15 times 5 times 2 times 2 is 60. So 60 is the least common multiple. It's kind of a slick way of finding your least common denominator, least common multiple. The other way is a greatest common factor. Remember, a factor is one of these numbers, one of these smaller numbers that divide into it. We want to find the largest common factor. This could be like for reducing a fraction. What's the largest number that divides into both the numerator and denominator? To find the greatest common factor, or GCF, of, let's do 18 and 30. Now, factors divide into numbers, so factors have to be smaller than the numbers. 18 we already factored is 2 times 3 times 3. 30 we already factored is 2 times 3 times 5. So the 2's are in common, the 3's are in common. Right? They both have a 2's, they both have a 3. Yep. What's 2 times 3? 6. 6 is the greatest common factor. When we're looking at greatest common factor, we're only looking at the common factors. When we looked at least common multiple, we found the common factors and then we had to combine the other ones to make them all have the same things. Greatest common factor, we just find the common factors and multiply them back together. Let's do another example. Let's find the greatest common factor of 48 and 60. So we're going to factor 48, and we're going to factor 60. 48 would be, what, 6 times 8? Either of those prime? No. 6 splits into 2 times 3. 8 splits into 2 and 4. 2 is prime. 4 splits into 2 and 2. So what we have there is 2 times 2 times 2 times 2 times 3. 60 splits into 10 times 6. 10 splits into 2 and 5. Those are prime. 6 splits into 2 and 3. So 60 is 2 times 2 times 3 times 5. What do they have in common? A 2, another 2, and a 3. So that means our greatest common factor is 2 times 2 times 3, otherwise known as 12. Better than a sharp stick in the eye? Well, we'll keep it short today in order to give you a little time to study for the test if you want to. On page 26, 1 through 63, the odds. They'll go really quick.